Hey everyone, welcome to this course. Today we're diving into the foundations of Python, a programming language known for its simplicity and versatility. Python is often called the plain English of coding languages because it's easy to read, write, and understand, making it perfect for beginners. Created by Guido van Rossum in 1991, Python has grown to become one of the most popular languages in the world. Whether you're developing websites, analyzing data, or automating tasks, Python is a powerful tool that can help you do it all. Why is Python so popular? It's easy to learn. The syntax feels natural, like writing a sentence. It's versatile. You can use it for almost anything: web development, AI, automation, data analysis, you name it. It has a huge community, so if you're stuck, there's always someone who's been there and solved it. It works on any operating system, whether you're on Windows, macOS, or Linux. Lastly, it's in demand. Companies love Python developers, so you're learning a skill that's practical and valuable. All right, let's get Python up and running on your computer. First, head over to the official Python website. Click on the big download button. Python usually detects your operating system, Windows, macOS, or Linux, and gives you the right version. Once the download finishes, open the installer. On Windows, don't forget to check the box that says Add Python to Path. This step is crucial. Now let's check if Python is installed. Open your terminal or command prompt on Windows and type Python -- version. If you see Python followed by a version number, congrats, you're all set. While you can write Python code in any text editor, I recommend using VS Code, Visual Studio Code. It's lightweight, beginner-friendly, and has excellent Python support. Just download it from code.visualstudio.com, install it, and you're good to go. In VS Code, search for the Python extension in the Extensions tab and install it. This adds handy features like code suggestions, debugging tools, and more. Let's dive into the essentials of Python programming. We'll keep it simple and practical. First, we have variables and data types. Variables are like containers. They store values you want to use later. In Python, you don't need to explicitly declare the type of a variable when you create it. This is because Python is a dynamically typed language, which means it determines the type of a variable based on the value assigned to it at runtime. For example, open a terminal and type Python. This opens the Python interpreter. You'll see 3 right arrows. To illustrate Python's dynamically typed nature, let's see some examples. If you have x equals 10, Python sees this as an integer. If you have x equals hello, now Python changes it to a string. Python takes care of figuring out the type behind the scenes. This flexibility ties into the concept of duck typing, a feature of Python's dynamic typing system. Duck typing is based on the duck test, which is frequently cited as an example of abductive reasoning. Its expression is, if it looks like a duck, swims like a duck, and quacks like a duck, then it probably is a duck. The test implies that a person can identify an unknown subject by observing that subject's habitual characteristics. In programming terms, This means that Python doesn't check the type of an object explicitly. Instead, it checks if the object has the required methods or behaviors to perform an operation. Moving on, here are the most common data types. Integers are whole numbers. For example, age equals 25. Floats are numbers with decimals. For example, price equals 19.99. Strings are text. For example, name equals Alice. Booleans are true or false values. For example, is active equals true. Now try this in your Python interactive shell. Age equals 25. Price equals 19.99. Name equals Alice. Is active equals true. Then print age, price, name, and is active. This should show the values of each of the variables. Easy, right? Before moving any further, let's learn a little about creating and running Python scripts. This will be helpful when we have to write long blocks of Python code that are difficult to write in the interactive shell. To write and run a Python script, start by creating a new directory that will house your scripts. Then open the directory in your code editor or IDE like Visual Studio Code, PyCharm, or even a simple text editor like Notepad. Create and save a new file with the .py extension, like my script.py. Write some code in the file, save it by pressing Ctrl+S on PC or Command+S on a Mac. To execute the script, open your terminal or command prompt, navigate to the folder where your file is saved using the cd command. For example, I saved my project in my desktop directory. I can navigate to the project directory by typing cd:/desktop/Python app, then pressing Enter or Return on my keyboard. To see what you have in your project directory, use the ls command. You should see the Python file you created earlier. If your project is open in Visual Studio Code, you can open the terminal in the project directory by navigating to Terminal in the menu and selecting New Terminal. This will open a new terminal window within Visual Studio Code, set to your project directory. Run the script by typing Python, followed by my script.py, then press Enter or Return. I wanted to mention this because we'll be alternating between writing scripts in our code editor and using the interactive shell, depending on the complexity of the code we shall be working with. Before we go any further, let's talk about an important feature of Python that distinguishes it from other languages: indentation. Indentation in Python is essential because it defines the structure and flow of the code. Unlike many other programming languages that use curly braces or keywords to define code blocks, Python uses whitespace indentation to group statements. This makes Python code more readable and clean, but also enforces strict syntax rules. Key points about indentation in Python. Defining code blocks. Indentation is required for all control structures such as loops, for, while, conditionals, if, elif, else, functions, classes, and more. The level of indentation determines which statements are part of the same block. Consistent indentation. You must use the same amount of spaces or tabs throughout the block. Mixing tabs and spaces will raise an indentation error. Python's convention is to use 4 spaces per indentation level, as recommended in PEP8, Python's style guide. You can also use tabs, but avoid mixing tabs and spaces. Misaligned or missing indentation causes errors. Python allows multiple levels of indentation for nested blocks. Now let's look at input and output functions. Python makes it super simple to interact with users. Use the print function to display things on the screen. Use the input function to get user input. Next up, let's talk about comments and code organization. Comments are your way of leaving notes in the code. Python ignores them when running the program. There are 2 types of comments in Python: single line and multi-line comments. To write a single line comment, use the hash symbol at the state of a line. To write multi-line comments, use triple quotes. Why use comments? To explain what your code does, especially if you're coming back to it later or sharing it with others. When it comes to code organization, there's a comprehensive guide titled Style Guide for Python Code on the official Python website. Be sure to check it out after completing this course. For now, all you need to remember is to break your code into small manageable sections and use meaningful variable names. Now let's dive into one of the most important topics in programming: control structures. As a quick note, we might use some functions that you might find a bit new at first, but don't worry. If you don't fully understand something right away, that's totally normal. Just take it step by step, and remember, you can always revisit the concepts later as we go along. The important thing is to keep moving forward and not to panic. Python is an extensive language, and you'll continue learning new things even after you're employed or working on advanced projects. So, embrace the learning process and remember that growth comes with practice. Now, let's get back to control structures. Control structures are how we make decisions and repeat tasks in our programs. Without them, we'd be stuck writing linear code, one step at a time. Let's go over the basics, and by the end of this video, you'll understand how to use if statements, loops, and more to create dynamic programs. Ready? Let's get started. First up, let's talk about if statements. The if statement is the most basic control structure, and it helps your program make decisions. The syntax is simple. If a condition is true, the code inside the block will run. Here's an example. So, in this case, if the value of age is 18 or greater, it will print "You're an adult." Otherwise, it won't print anything. But what if we want to handle the else case? Well, that's where else comes in. In this example, if the condition is false, it'll print "You're a minor." Now, what if we want to check multiple conditions? We can use elif to chain more conditions together. Next, let's talk about loops. Loops allow us to repeat code. There are two main types of loops in Python: for loops and while loops. Let's start with a for loop. A for loop iterates over a sequence, like a list or a range of numbers. Here's an example. In this case, the loop will print numbers from 0 to 4, because range 5 generates the numbers 0, 1, 2, 3, and 4. You can also loop through other data structures, such as lists. A list is a built-in data structure that allows you to store an ordered collection of items, which can be of any type, such as integers, strings, and other lists. For now, let's just use a list to illustrate how we can loop over it in Python, but we'll cover lists in more detail later on in this course. This will print each fruit in the list. Now, what if we want to repeat code based on a condition? That's where while loops come in. The while loop will continue as long as the condition is true. In this case, it will keep printing the value of count until it reaches 5. Be careful with while loops, because if the condition never becomes false, the loop will run forever. The statement count plus equals 1 is crucial in your loop because it updates the value of count during each iteration, moving the loop closer to its stopping condition, count less than 5. Without this increment, the value of count would remain constant, causing the loop condition, count less than 5, to always evaluate to true. This would create an infinite loop, where the program repeatedly prints the same value of count forever. Let's look at a practical example. Here's a block of code where I have removed the count plus equals 1 statement. If I hadn't interrupted it by pressing Command plus Z, the script would have printed 0 forever. Having said that, let's proceed with our lesson. Now let's look at a few special statements that can be used inside loops: break, continue, and pass. The break statement will stop the loop completely. The continue statement will skip the current iteration and move on to the next one. The pass statement is a placeholder. Nothing happens when it's executed, but it's useful in situations where you need to define a block of code but haven't yet implemented it. Let's look at this practically. Let's try to write some code that prints 0 to 4 on the screen. Let's see how we can make this code to stop printing at 3 using the if and break statements. This will print 0, 1, 2, and stop when I reaches 3. Now let's modify the code to skip 3 using if and continue statements. This will print 0, 1, 2, 4, but skip 3. Lastly, let's see some use of the pass statement. In this case, our program will print all numbers from 0 to 4, since the pass statement will do nothing when I equals 3. All right, now you've got the basics of control structures. You can make decisions with if, repeat tasks with loops, and fine-tune your loops with break, continue, and pass. These are essential tools that will help you control the flow of your programs and make them more efficient. Let's look at another control structure, the match statement. In Python, the match statement is a way to check a value against a series of patterns and execute code based on which pattern matches. It's like an upgraded version of if, elif, else, but much more powerful and readable. In this code, the match keyword checks the value of command. The case statements define the patterns to match. The underscore symbol acts as a wildcard, matching anything that wasn't caught by the earlier cases. Think of it as a default case. Now let's talk about functions. First off, what exactly is a function? In simple terms, a function is a block of code that only runs when it is called. You can think of it like a recipe. The function is the recipe, and calling the function is like following those steps to make something. Functions help you avoid writing repetitive code. Let's start by defining a simple function. Here we've defined a function called greet. The def keyword is used to define a function, followed by the function name and then parentheses. Inside the function, we have the code that will run when the function is called, but notice this function doesn't take any input and doesn't return anything. We'll get to those features in just a moment. Now, to actually use this function, we need to call it. Calling a function is as simple as typing the function name followed by parentheses. When you run this code, it prints the greeting message. So the function is like a reusable piece of code, and you can call it as many times as you need without rewriting it. Now let's make things a bit more interesting by adding parameters. Parameters allow us to pass information to the function when we call it. Let's update our greet function to accept a name as a parameter. The value in the print line of code is an example of f-string formatting, which is a convenient way to embed variables directly into strings in Python. This is also known as string interpolation. String interpolation is the process of inserting values of variables or expressions into a string. The f before the string tells Python that we're using an f-string, which allows us to insert the value of variables directly into the string. The name variable enclosed in curly braces allows us to place the value of name right. Now, when we call the function, we'll pass in a name, and it will greet that person specifically. Let's see how this works. With this change, we've made the greet function more flexible. We can now reuse it to greet anyone, not just a fixed name. Next, let's talk about return values. Sometimes we want a function to do some work and then give us back a result. In Python, we use the return keyword to send back a value from a function. Let's define a function that adds two numbers and returns the result. Now we can call the function and store the result in a variable. As you can see, the add function takes two arguments, adds them together, and returns the result. This allows us to use the result later in our code. What if we want to set default values for our function parameters? This is useful when we don't always want to pass every argument every time we call the function. Here's how we can set default arguments. Now if we call greet without passing a name, it will use the default value of guest. But if we pass in a name, it uses the one we provide. Another important concept is variable scope. Variables defined inside a function are local to that function, meaning they can't be accessed outside. Let's look at an example. In this example, the variable greeting is local to the greet function. If we try to access it outside the function, Python will give us an error. All right, now you know how to define functions in Python, pass parameters, return values, and even set default arguments. Functions are powerful tools for organizing and reusing your code, and they're a big part of writing clean, efficient programs. Now let's talk about data structures in Python. Data structures are essential for organizing and storing data efficiently. We'll go over some of the most commonly used ones: lists, tuples, dictionaries, and sets. First up, let's talk about lists. A list is a collection of items that are ordered, changeable, and can contain duplicates. You can think of a list as a collection of items in a grocery list, where you can add, remove, or change items whenever you want. Here's how you define a list in Python. Lists are enclosed in square brackets, and each item is separated by a comma. You can store any type of data in a list: numbers, strings, or even other lists. Before we proceed any further, it's important to remember that in Python, everything is an object, which means every piece of data we use is an instance of some class. When we create variables or use built-in types like strings, numbers, lists, and even functions, Python treats them as objects. What makes this powerful is that because everything is an object, it means that all data types in Python have associated functions that can be called on them. We will talk more about objects and classes later in the course. From this knowledge, we can see that lists are not just simple collections of data. They are actually objects. This means that they come with a lot of built-in functionality, or methods, that allow you to perform various operations on the list. Because lists are objects, they can store both data and the behavior associated with that data. For example, a list has several methods that let you modify its contents or gather information about it. Append, which adds an item to the end of the list. Remove removes the first occurrence of a specified item. Pop removes and returns the last item, or a specific item by index. Sort sorts the list in ascending order. Reverse reverses the order of the items in the list. Insert inserts an item at a specific position in the list. Lists are ordered, meaning the items stay in the order they were added. They are also mutable, so you can change the contents of a list after it's created. Remember, you'll be working with these data structures frequently throughout your learning and coding journey. For now, simply introducing them is sufficient. We'll explore them in much greater detail in future lessons. I also recommend exploring Python's built-in types further. You'll find more in-depth explanations and examples in Python's official documentation, which can help you deepen your understanding as you continue your coding journey. The link is available in the description. Next, let's look at tuples. A tuple is an immutable sequence in Python. Think of it as a list that you can't change once it's created. It's defined using parentheses instead of square brackets. Here's an example. Tuples can hold different types of data. If you're wondering why we use tuples, the immutability can be great for storing data that shouldn't change, like coordinates or configuration settings. Creating tuples. You can create tuples in different ways, with parentheses, without parentheses, also known as tuple packing. Empty tuples. And single element tuples. For the single element, be careful not to forget the comma. To access elements in a tuple, you can use indexing slicing, negative indexing. Remember, tuples are immutable, so trying to update their contents won't work. Tuples are great for storing fixed data like days of the week or RGB values, returning multiple values from a function, and using as dictionary keys since they're hashable. Here's a quick example of returning multiple values. If you try to modify a tuple, Python will raise an error. Tuples are faster than lists because they are immutable, so use them when you don't need to change the contents. Tuples, lists, and ranges are all part of what Python refers to as sequence types. These types share a collection of powerful operations that allow us to interact with and manipulate them in intuitive ways. Let me show you some of these common operations with brief explanations. Membership. This checks if a value exists in the sequence or if it's absent. Concatenation. This combines two sequences into one. Repetition. S times n or n times s. This repeats the sequence n times. Indexing. Access the element at position I, starting from 0. Slicing. Extract a portion of the sequence from index I to j. In this case, I and j represent the positions or indexes of items in the list. In Python, indexes start at 0. I is the position where you start taking items, inclusive, meaning the item at index I is included in the result. J is the position where you stop, but the item at index j is not included in the result. In other words, exclusive. Extended slicing. Extract a portion of the sequence with a step size of k. This example instructs Python to take items from sequence S, beginning with the item at position 1, ending with, but not including the item at position 6, taking every second item. The second example instructs Python to perform the same operation as the previous example, but in the reverse order. Meaning, take items from sequence S, beginning with the item at position 6, ending with, but not including the item at position 1, taking every second item in reverse order. When the values of I and j are not specified, the whole sequence will be considered. This means Python will run through the whole sequence, taking every kth value. Length. Get the number of elements in the sequence. Minimum and maximum. Find the smallest and largest elements in the sequence. Count occurrences. Count how many times X appears in the sequence. Now let's talk about dictionaries. Dictionaries are key-value pairs, where each key is unique and maps to a value. They're super useful when you want to store related data, like storing a person's name and their age. Here's how you define a dictionary in Python. Dictionaries use curly braces, and the items are defined with a key and a value, separated by a colon. There are several ways to create dictionaries. Using curly braces, using the dict function. You can also create an empty dictionary. You can access values in a dictionary using their keys. If you try to access a non-existent key, you'll get an error. To avoid this, use the get method. Dictionaries are unordered and mutable, so you can add, remove, or update key value pairs at any time. The keys must be unique, but the values can be anything: numbers, strings, lists, or even other dictionaries. Python provides several dictionary methods to manipulate and access data efficiently. Here's a categorized list of these methods, along with brief explanations. Get returns the value for the specified key. If the key is not found, it returns the provided default value, or none if no default is provided. Keys returns a view object of all keys in the dictionary. Values returns a view object of all values in the dictionary. Items returns a view object of all key value pairs as tuples. Update updates the dictionary with key value pairs from another dictionary or an iterable of key value pairs. It overwrites values for existing keys. Set default returns the value of a key if it exists. Otherwise, inserts the key with a default value and returns that value. Pop removes the key and returns its value. If the key is not found, it returns the default value or raises a key error if no default is provided. Pop item removes and returns the last inserted key value pair as a tuple. It raises a key error if the dictionary is empty. Clear removes all items from the dictionary. Copy returns a shallow copy of the dictionary. From keys creates a new dictionary with keys from the iterable and the same value for all keys. Finally, let's talk about sets. A set is an unordered collection of unique items. Unlike lists and dictionaries, sets don't store duplicates, and the order of items is not guaranteed. Here's how you define a set. Sets are defined using curly braces, just like dictionaries, but they don't have key value pairs, only unique values. Let's see how sets handle duplicates. As you can see, sets automatically remove duplicate values. Since sets are unordered, you can't access elements by index, like you would in a list. There are a few ways to create sets in Python. Using curly braces, using the set function. You can also create an empty set. Note that you can't create an empty set using empty curly braces, as that would create a dictionary. Python provides several methods to enable us to perform operations on sets. Add adds elements to a set. Remove removes elements from a set. It throws an error if the element does not exist. Discard removes elements from a set. It doesn't throw an error if the element does not exist. Clear remove all elements from a set. Union combines all unique elements from two sets. Intersection finds common elements. Difference finds elements present in one set but not the other. Symmetric difference finds elements present in either set but not both. You can also check for membership or subset relationships. Check for membership using the in and not in operators. Check for subsets and supersets using the isSubset and isSuperset methods. Sets are mutable, so you can add or remove elements. If you need an immutable version of a set, use a frozen set. Now that we've covered the basics of each data structure, you might be wondering, when should you use each one? Here are some quick guidelines. Use a list when you need an ordered changeable collection that can hold duplicates. Use a tuple when you need an ordered unchangeable collection of items. Use a dictionary when you need to store key-value pairs, where keys are unique and you need fast access. Use a set when you need a collection of unique items and don't care about order. Now let's dive into file handling in Python. Files are everywhere in programming, whether you're saving data, reading from logs, or processing files like CSVs or JSON. Python makes it really easy to work with files. First, let's talk about opening and closing files. Before you can work with a file, you need to open it. In Python, we use the open function for that. The open function takes two main arguments, the file path and the mode in which you want to open the file. Here's a simple example of opening a file for reading. The R mode tells Python that we want to read the file. There are other modes as well. R tells Python to open the file in read mode. This is the default mode. It opens the file for reading and gives an error if the file doesn't exist. W tells Python to open the file in write mode, opens the file for writing and creates a new file if it doesn't exist, or truncates the file if it does. A tells Python to open the file in append mode, opens the file for writing but doesn't truncate the file. It adds content to the end. B tells Python to open the file in binary mode, used for working with non-text files like images. Now let's try reading from the file. To read from a file, you can use several methods: read, readline, and readlines. Let's go through each of them. First, let's use read to read the entire contents of a file. When you're done with a file, it's important to close it with the close method to free up system resources. The read method reads the whole file as a string. If the file is large, this could consume a lot of memory. So, be mindful when working with large files. Next, we can use readline to read one line at a time. The readline method reads the next line each time it's called. It's useful if you want to process the file line by line. Finally, we can use readlines to get a list of all lines in a file. With readlines, we get a list where each element is a line in the file. This is useful if you need to work with individual lines. Now let's talk about writing to files. If you open a file in write mode, W, you can write data to it. Be careful though. If the file already exists, it will be overwritten. Let's write some text to a new file. The write method will write the string to the file. If the file doesn't exist, it will be created. If it does exist, the contents will be replaced. To append to a file instead of overwriting it, we can use the A mode. In this case, the new content is added to the end of the file instead of replacing the existing content. While the open and close methods are perfectly fine, Python offers a better way to handle files using the with statement. The with statement automatically takes care of opening and closing the file for you, so you don't have to worry about forgetting to close it. Notice that we don't need to explicitly call file.close. It happens automatically when the with block is exited. This is considered best practice for file handling. Finally, let's discuss error handling. When working with files, things can go wrong. Maybe the file doesn't exist, or you don't have the proper permissions. To prevent your program from crashing, you should handle these situations using try and except blocks. Here's how you can handle file errors. In this example, if the file doesn't exist, Python will print a custom error message instead of crashing. Now let's dive into an essential concept in programming, object-oriented programming, or OOP. OOP is a paradigm that helps organize code by modeling real-world objects and their behaviors. It's a powerful way to structure your code, and Python makes it easy to get started. By the end of this video, you'll understand the basics of OOP, including classes, objects, methods, and more. Let's get started. So, what exactly is object-oriented programming? In OOP, we think of everything as an object. An object is an instance of a class, which is like a blueprint for creating objects. Objects have attributes, also known as properties, and methods, functions that describe the behavior of the object. Here's an example. Imagine we have a car class. A car has attributes like color, model, and make, and it has methods like drive and stop. Each car object we create from the car class will have its own color, model, and the ability to drive and stop. Let's start with how to define a class in Python. In Python, we use the class keyword to define a class. Here's an example of how to define a simple class for a car. In this code, we've defined a class called car. Inside the class, we have an init method. This is the constructor. It's called when an object is created from the class. It initializes the object's attributes, in this case, make, model, and color. We also have methods like drive and stop, which represent the behavior of the car. Let's create some car objects. Here we've created two car objects, car1 and car2. Each object has its own values for make, model, and color. We can now call the drive and stop methods on each object. Now, let's go into more detail about attributes and methods. As we saw, attributes are the data that belong to an object. Methods are the actions that an object can perform. Let's say we want to access or modify the attributes of an object after it's created. We can do that directly using dot notation. One of the most powerful features of OOP is inheritance. Inheritance allows you to create a new class based on an existing class. The new class inherits the properties and methods of the original class, but you can also add or modify its own features. Here's an example of inheritance. Let's say we have a sports car class that inherits from the car class. In this example, sports car is inheriting from car. The super.init method calls the constructor of the parent class, car, to initialize the common attributes. We've also added a new attribute, top speed, and we've overridden the drive method to make it specific to sports cars. Let's create a sports car object. Now we have a sports car object that not only has the attributes of a regular car, but also has its own special behavior. This is a great way to reuse code and extend functionality. Another important OOP concept is polymorphism, which means that objects of different classes can be treated as objects of a common superclass. Polymorphism allows you to define methods in the child class that have the same name as methods in the parent class, but with different behavior. Here's an example. In this case, both sports car and electric car have a drive method, but they behave differently. Polymorphism allows us to use the same method name for different types of objects, making the code more flexible. Let's now talk about two crucial topics every Python programmer needs to know: error handling and debugging. Whether you're building small scripts or complex applications, handling errors gracefully and debugging your code are essential skills to master. First, let's talk about what errors are. In Python, an error occurs when something goes wrong during the execution of your program. These errors can prevent your program from running smoothly. Errors can be divided into two main types. Syntax errors. These happen when the code doesn't follow Python's rules of structure. For example, missing a parenthesis or a colon. Exceptions. These happen when the code is syntactically correct, but encounters an issue while running. For example, trying to divide by 0 or accessing an element in a list that doesn't exist. Now that we know what errors are, let's talk about how to handle them. Python provides a powerful mechanism for handling exceptions using the try and except blocks. This allows you to catch errors and deal with them instead of letting your program crash. Here's an example of a try except block. In this example, we ask the user to input a number. Inside the try block, we attempt to divide 10 by the number entered. But what if the user enters 0 or a non-numeric value? We catch those potential errors with specific except blocks. If the user enters 0, a division by 0 error occurs. If the user enters something that isn't a number, like a string, a value error is raised. This way, instead of crashing, the program gives the user a friendly error message. You can also catch multiple exceptions in a single except block, or handle them separately. Let's look at both approaches. Here's how to catch multiple exceptions in a single block. In this case, we handle both zero division error and value error in one block and use the as keyword to capture the exception message. Sometimes you may want to execute certain code no matter what happens, even if an error occurs. That's where the finally block comes in. The finally block is always executed, whether an error occurs or not. Here's an example. In this example, no matter what happens, whether the file is found or not, the program will always close the file in the finally block. It's a good place to put cleanup code, like closing files or releasing resources. You can also raise exceptions manually in your code if something goes wrong. This can be useful for adding custom error handling in your programs. Here's how you can raise an exception. In this case, if the user enters a negative number, the check positive function will raise a value error with a custom message. This gives you more control over how errors are handled in your program. Now that we know how to handle errors, let's move on to debugging. Debugging is the process of identifying and fixing problems in your code. Here are a few techniques to help you debug your Python programs effectively. The simplest way to debug is by using print statements. By printing out the values of variables at different points in your program, you can track what's going wrong. Another way to debug your code is by using Python's built-in debugger, PDB. You can set breakpoints and step through your code line by line. In order to use this debugger, we need to import it into our script. In Python, importing is how we bring external code or libraries into our program so we can use their functionality. Python comes with many built-in libraries or modules that provide useful tools and features that we don't have to write ourselves. When you want to use one of these libraries, you simply import it. To import a module, we use the import statement. Let's go ahead and import the PDB module. When you run the code with pdb.setTrace, the program will pause and you can interact with the program to inspect variables and step through each line. The last debugging technique is using IDE debuggers. Most integrated development environments, like PyCharm or VS Code, have built-in debuggers that make it easier to set breakpoints, inspect variables, and step through your code visually. And that's a wrap for the Introduction to Programming with Python course. Congratulations on completing this course. You've taken the first steps into an incredible world of programming, and I'm so proud of the progress you've made. But remember, learning doesn't stop here. To really master Python, it's important to keep practicing. Here are some next steps you can take. Dive into the official Python documentation. It's a treasure trove of detailed information and examples straight from the creators of Python. Solve coding problems on LeetCode or similar platforms. This will help you sharpen your problem-solving skills and understand how Python can be applied in real-world scenarios. Explore frameworks like Django. If you're interested in web development, Django is an excellent way to learn how Python can help you build powerful websites and web apps. You can find the links to these resources in the description below. We're going to post more Python-related content on this channel, covering advanced topics, projects, and even frameworks like Django. So, be sure to like, subscribe, and hit the notification bell to stay updated. Trust me, you don't want to miss out on what's coming next. Thank you so much for joining me on this journey. Now, go out there, write some Python code, and make something amazing. I'll see you in the next video.